421 misdirected request is an error code that indicates that a request has been sent to a server that is not able to produce a response. This shows up quite easily in the world of SNI, where the connection might indicate one server, but then suddenly at the application layer, we start to ask for resources from another server. To demonstrate, we'll use OpenSSL S-Client to connect to my Apache server, where the server name has been selected as server2 wsw.local. Once connected, we will now ask for the root URL, but on server1 wsw.local. Because the initial SNI handshake selected server2, the request to server1 is simply not permitted at this point. The 422 Unprocessable Content response code is an application-level response where the application would have understood the message, but perhaps there is something wrong with the content, such as a checksum mismatch or data is outside some allowed range. For this demonstration, I've created a small application on the server that accepts a post operation to create a new user. When we send in a user with a valid age parameter, we get back the 201 to indicate that the resource has been created. However, if we attempt to send in a negative age, we get back a 422 Unprocessable Content. While the JSON itself is valid, the meaning of the data is not. A malformed JSON syntax body would be better represented with a 400 bad request response. In WebDAV, it is possible to lock a document so that people cannot modify it, perhaps because you are currently updating it. When a client attempts to modify or delete a document that is locked, the server should return the response code 423. We have the tool CyberDuck opened, and we can see a file called data.txt. We would like to lock this file, but while the Apache WebDAV server knows how to deal with lock requests, CyberDuck doesn't support it, so I'm going to have to resort to the manual web client to lock the document. Once we get back to 200 OK to say that the document is locked, we try to delete the file from CyberDuck. CyberDuck clearly shows the 423 response code. If we unlock the file, which requires the lock token from the locking operation, we get the 204 no content, which of course means that the operation was successful and has no body. We are now able to delete the file from CyberDuck. The 424 Failed Dependency code is another typical WebDAV response code, but could be used in an application when it makes sense. The code indicates that the request failed because another operation that depended on also failed. In the case of WebDAV, the typical problem appears from a multi-status request. For the sample, we have the Apache WebDAV server running with a resource called data.txt. Since my usual CyberDuck tool doesn't actually generate these requests, I will use the manual web client to do a prop patch to set the author name and remove the E tag. Removing the E tag is simply not possible, so therefore the author name change should also fail. The response comes back inside a 207 multi-status, and you can see the author change has failed with the 424. The 425 too early response code is really targeting the zero round-trip time features of the HTTP version 3 protocol. This particular response code is pretty difficult to demonstrate in an actual connection, so we'll just use an animation this time. Suppose we have a client that needs to perform some payment operation, but there's already an established TLS connection. To reuse the connection, the client must use a resumption ticket, but the 0RTT protocol allows the client to send the HTTP message right away, which may not be processed if it shows up too soon. The server has the option to send back a 425 too early to indicate to the client that their message came in too soon and that they should resend the message once the session has been reestablished. The 426 upgrade required is an indication from the server that the current message is not going to be used unless the client changes to a different protocol. The change could involve a switch from HTTP 1 to HTTP 2, or more likely a WebSocket protocol. In the example, I have configured a web application that uses WebSockets. When we attempt to acquire the slash route, we get back a 426 upgrade required. By default, the node's WS package that generates the 426 should really have included an upgrade header informing the client what is expected, but this one just happens to be nothing. It is possible to see the 428 precondition failed response code in web applications that use the if match header and the client attempts to use the operation without it. Let's suppose that we have an API that uses a get and put operation to retrieve and update a user inside the application. We'll start by asking for user 42 and we can see a name and an age. A put operation is normally used to update part of the resource, so we'll attempt to do a put with the new value. This results in a 428 precondition required. This is an indication that we must include an if match header to specifically indicate the version of the resource we're trying to update. Checking back with the get result, we see that the response included an e-tag header, which could be created using a hash of the data or maybe some other random value associated with the current values of the name and age. This value needs to be sent back as part of the if match header, which will cause the server to agree to the change and send back the 204 no content. The 429 too many requests response is sent by a server if the client is simply making too many requests over a certain period of time. The response is essentially asking the client to slow down the request for whatever reason. I've configured a web application this time to allow only one request every 2 seconds. If we click slowly enough, we are given random weather information each time we click, but if we click too quickly, we get back the 429 code instead. This code is frequently given to public APIs and free accounts where the service provider is basically trying to prevent you from overwhelming their server, unless of course you're willing to pay more money. The 431 request header field's too large is a response code that is returned by the server when the header is basically too large. It could be that there's too many headers, or maybe the headers themselves are just too big. To demonstrate this, I'm sending a new header with 9,000 characters using the curl command. The one thing that I found while making the video is that the response code for 431 seems to be only returned when using the HTTP2 module from Apache. Using the HTTP protocol, or even using Postman, kept resulting in a 400 bad request. So you might find it kind of awkward to create a response of 431. The code 451 unavailable for legal reasons is a code that is used to inform the client that the request resource is not available, well, for obviously legal reasons. For example, perhaps a certain document is only permitted to be available in certain jurisdictions. The code number itself actually comes from Ray Bradbury's book Fahrenheit 451, where books are banned. To generate this particular code, I ended up having to put in a specific rule for Nginx to generate the code. Even Postman doesn't know what to say about it in the explanation. Generally, you're more likely to find a 403 if the server doesn't want to actually send you a resource for some reason.